Hello, everybody. Hope that you're doing well today. It's going to be a great show today. We have Josiah Neeley who'll be joining us. We're going to be talking about all things energy, which is, anyone who's watched the channel knows, is something that I tend to harp on fairly regularly. So, Josiah, thanks for coming on. I appreciate it very much. Why don't you go ahead and NetFan, let me know if there's any issues with the sound. I think that it should be in pretty good shape. Josiah, why don't you go ahead and introduce yourself? Tell us who you are and why we should pay attention to the things that you say or write.
Sure. So first, thank you for having me. I'm sure it's going to be an enjoyable event. So I am Josiah Neeley. I am a senior fellow with the R Street Institute, which is a think tank based out of Washington, D.C., although we have people located throughout the country. So I'm here in Austin, Texas. And I work mostly on energy issues with the emphasis on electricity, but also talk more broadly about energy and energy policy stuff. I've been doing that for about 10 years now. I have a legal background. I am a ex-lawyer, you might say.
Uh-huh.
I don't know. And they still make me pay. They still make me pay the bar dues, I guess. So I don't know if that makes me an ex-lawyer or still in,
Uh-huh.
But and I am, of course, also here in Texas. So the reality. People are a lot more interested, I find, in electricity policy than they were a month ago.
Yeah. Uh-huh. Yeah. Well, that's I guess that's kind of how things go. So before you did law school, what did you do before law school? What was your background, education background?
Before law school? Oh, well, I went to college. I have a degree in philosophy, if that's what you're.
Okay. Yeah. So philosophy, law, education policy.
Right.
I'm sorry, energy policy. Energy policy.
Yeah, right.
So what is a think tank? Because the only think tanks that I'm really familiar with are like the Brookings Institute. UNLV has a Brookings satellite campus. We have an agreement with Brookings here, and like the Heritage Foundation and the Manhattan Institute.
Right.
What is the? But these are all located in kind of spread out. I guess Brookings is in DC as well. But what is the R Street? Is it the R Street?
Yeah, it's letter R Street.
And that's the whole thing. That's like, it's not R Street Inc. It's not R Street.
It's the R Street Institute.
R Street Institute. Okay.
Yeah. And R Street started in 2012, I believe, as an independent organization, but we previously were a division of a larger organization. Well, at the time, a larger organization called Heartland. And R Street, what is now R Street, started out as a division within Heartland that focused on insurance reform issues, property insurance, so windstorm, flood, that sort of thing.
Uh-huh.
And Heartland, in addition to the insurance stuff that we did, one of the major things that they did was talk about climate change. Often, from a pretty skeptical, one might even say, some might say dismissive perspective.
Mm-hmm.
And at some point, they did a billboard campaign where they had there was a series of billboards that featured Charles Manson and Ted Kaczynski, the Unabomber, and Osama bin Laden. They would just have pictures of them on these billboards, and then the billboards would basically say, I believe in global warming, do you? Right? Like, I guess the implication being
that you're on the side of the terrorists if you believe in global warming.
Of like terrorists or serial killers, or that caused a big controversy at the time within the organization. And one thing, just kind of there had already been, I think, a bit of a tension between the work that we were doing on insurance reform and the other climate stuff, because if you want to have credibility in dealing with property and casualty insurance, you kind of got to take climate into the equation, because sea level rise or the effect that warmer temperatures will have on storms, right? These are affect the bottom line of what it costs to insure properties.
Yeah.
So we decided at that point to kind of go our separate ways, and so we, became an independent organization. And when we did that, we had a choice of, do we want to just stay focused on insurance reform, or do we want to branch out into other areas, right? And we decided we wanted to branch out. And so one of the early areas that we thought was a logical progression has to do with climate and energy, where I work. But we now, almost 10 years later, our street works on all sorts of issues, so we work on criminal justice, we work on public health, we work on governance reform issues, on intellectual property, all sorts of stuff that, is far afield from insurance reform.
Now, does that work by, like, they'll bring someone on who has a particular interest in that area, and then they're kind of the nexus of the...
Yes. Yeah. So, and
is there much crosstalk between different members? Like, if you have a think, I've never worked in a think tank before. I've only, and so, like, do they have meetings where you just toss ideas around or like approach your colleagues and say, hey, what's wrong with my idea here?
So definitely, and I should say, over the course of the 10 years, the answer has kind of changed somewhat. When the organization started, I think there were 6 people, and now it's probably closer to 60, something like that. So it's grown a lot, and I find that when the size of an organization grows, the internal workings of it kind of have to change. So when we were a smaller organization, there would be a lot more of kind of what you described, brainstorming, sessions, that sort of thing. And that's harder to do when you have more and more people. And so you end up having like a more structured process. There was, at one point there was there was a guy who worked there who part of his job was evaluating, new areas that we might want to move into and figure out how it related to our current work. So we do that. Sometimes there will be issues that will cross they will affect multiple departments, and then we kind of work together on that as well.
Okay, and then how did you get started in energy policy? Like, what was your trajectory from law school to energy policy?
Yes. So I worked after I graduated from law school. I worked as an attorney for a while, about 7 years, depending on how you want to count it. Because I worked for a judge, and then I was in private practice. And I was from Texas, and I had moved away to go to law school. And then when I was looking to get married, my wife and I now wanted to move back to Texas. And so I was looking around for different things, and there was a position that kind of involved. It was energy and environmental policy, but it was legal oriented. Particularly, a lot of environmental policy is very legal heavy, because there's a lot of it's litigation driven. As APA, Administrative Procedure Act, very intensive in terms of like what are the procedural requirements or whatever. So I applied for that, and they thought that I would be a good fit having that legal background, even though I didn't have a subject matter background in, I didn't come out of like electric, I don't have a degree in electric engineering or climatology or anything like that. And that's how it happened.
Okay. So what can you tell me? So one of the things that I've talked about, and I mentioned this just yesterday in my class, the fact that the electric grid across the United States is divided into three major components. It bleeds, two of the components go into Canada. One of them bleeds a little bit into Baja California, but Mexico is largely independent of the United States grid, where Canada and us are pretty bound at the hip.
Right. It's basically
And then there's Texas, and the Texas grid doesn't cover all of the state of Texas, but my understanding is it does not leave the state of Texas. That everywhere where it ends at the state line, basically. So how did this come to be? So I could say what I thought the issue was, and maybe that's true or false. But what I'll do is I'll let you tell me what the history was, and then I'll agree with you and say, yeah, that's what I thought.
Very good. Yeah. So I think there's a little bit of a different answer for the Western and Eastern interconnect versus Texas. In the case of Texas,
so the interconnect is like the region of the country that's all interconnected.
Correct. Yes.
On its own, somewhat separate grid, although they are kind of tied together at certain locations.
They do have ties. Yes. Right. Yeah. So they do have ties, and we also have ties down with Mexico, some as well. But they're largely they're separate. And in the case of Texas, as you noted, our own grid covers most of the state. There are little parts around the edges that aren't covered, like El Paso is not part of it. Up in the Texas Panhandle, this part, but most of the state is part of this grid. And in that case, the reason is a political one, that a lot of federal jurisdiction and federal rules are based off the interstate sale and transmission of electricity. So if you have a purely intrastate grid, that jurisdiction doesn't apply, right? Mm-hmm. Interestingly, this is not true for electric reliability. So FERC is the federal regulator. They still have jurisdiction even within Texas over electric reliability issues, but it was felt back in the 1930s that Texas would be better off maintaining an independent grid, and that would free us from a lot of federal regulation, right? Mm-hmm. So from that perspective, occasionally people will talk about, well, should we join? It would probably be the Eastern Interconnect. That's probably the most logical for what it would be. Mm-hmm. The other two, like why there is a separation between the West and the East. There's not, I think that's just kind of a nature of how the grids end up getting built out. Mm-hmm. And I will say that while it's definitely useful to have a larger geographic footprint for electric grid, so that it helps you match supply and demand and achieve economic efficiencies and other things like that. Mm-hmm. There's kind of like diminishing returns with that, where if you have like a region.
So if I think about it, so my understanding, and this could be that part of the reason that the grids are divided like this is because the grid didn't start. Like they didn't start building the grid in the middle of Kansas and spreading out from there. They started at the populated areas, and then it filled in over the flyover country into the middle of everything. So you had basically a population center in Texas, you had a population center on the coast, on either coast in the Midwest, and then they kind of grew from there. And then eventually they meet up somewhere, because the country wasn't really fully electrified until like the 60s.
Right. Yeah, so that's my understanding too. And even now, there's a lot of areas in the middle part of the country that are not very population dense. Mm-hmm. The Dakotas and Kansas and whatever. So even though there are people there, it's not and there's definitely a lot of like wind there. Mm-hmm. So that's an interesting question of like for transmission or whatever. But in terms of, it's sort of the same thing that you had with the railroads back in the 19th century, where the railroads were built from the West Coast in and from the East Coast in, and then at certain places they kind of met up. Somewhere in the
Yeah.
Rocky Mountains.
So another thing that, and this would be a technical question that it makes me think, but I don't know what to think about it necessarily, is that the light travel time across the continent is going to be kind of a fraction of a second. So I wonder if you have a gigantic grid, if the footprint is too spread out, then maintaining phase between, you have all these power plants plugged into it, and maintaining the phase of across the power plant, I could imagine that you get some decoherence in the phase of the electric signal if you have two plants that are separated by a continent trying to go at 60 hertz perfectly lined up. That you may end up losing power in the grid because of some deconstructive interference between the different power plants. I don't know how the power plants are all maintained in phase. That's
so that's an interesting question. That's possible. Also, I mean, you do get like there's a little bit of line loss of power as you travel along the transmission lines. It's not that much, but I suppose it can kind of add up over long distances.
Do you know approximately what it is? Like what fraction of the energy is lost?
I want to say it's somewhere in the range. Well, gosh, let me see if I can look it up real quick.
And so, for the most part, power isn't transmitted across the Rockies. It basically stops. At that edge.
Let's see here.
So that's a number, like looking up the number, like how much energy is lost in transmission is something that every time I look it up, I see a different number, and no one reports it.
It kind of so I think it's one of those things where it's not linear in that the far, let's see, so I think it's in the range of, so you're probably looking potentially in the range of like 3 to 5%.
Okay.
For 1,000 kilometers, maybe, if I'm reading that right.
Okay, so let's say if it's 5%, let's see, if it's 3%, then that means that basically 1%, because a third of the energy consumption in the United States. So the Lawrence Livermore National Lab puts out that energy flow chart every year, and so electricity is about a third of all of the energy produced in the United States. And so if it's 3%, then it's like 1% of the total energy consumption goes to losses in the electric grid. Something like that.
So I'm a lawyer, but that math sounds right to me.
Okay, so now here's a question: is when you have more diffuse power, so like how does wind, especially with Texas where they've evolved quite a bit, how did the wind footprint in Texas develop? Like when did they start really investing in it, and what were some of the growing pains that were associated with adopting a new technology?
So it's interesting. So I think the first real life cycle or push or whatever, there was a push back in the late 70s to do a lot of wind. This was during the oil crisis. Fuel prices were pretty high. And even though we don't use a lot of oil for electricity, certainly not anymore, they also, natural gas prices were also pretty high. And so there was a lot of money put into trying to develop wind generation out west in West Texas. So
that's similar to what happened in like in the late 2000s, when we need to divest ourselves from the Middle East, and so we need to develop all sorts of internal. It became all the rage to turn corn into ethanol, despite the fact that it was more expensive.
Whenever the historically the price of oil gets pretty high for an extended period of time, people start thinking along these lines. Interestingly, that ended up kind of dying out when the price of oil went back down, and it really is best I understand it is kind of causally isolated from the wind turbine designs and everything that we use now are not really developed based on those older
They're not
designs.
the progeny of the previous
Right. Yeah.
generation.
Exactly. Yeah. It's not. Yeah. Right. So that happened. That went away, and then again, as you say, like in the early 2000s, you start to have more interest in that again. Um, in Texas, so just geographically, it's a big state. The wind, we have a lot of wind energy that tends to be out in the west, typically in the Panhandle.
Hmm.
That's not where the people are, so it's not where the electric, and it's not where the industry is mostly. Uh, so it's not where the electric demand is. Um, so we did have a pretty big build out first starting around the mid 2000s, and then uh, really probably around it accelerated more, I would say, around 2014. And I think part of the reason for that is that there was a project in Texas called CREZ, which built like a lot of big transmission lines from the population centers in central and eastern Texas out to West Texas,
Hmm.
and that would allow for that electricity that is generated out there from the wind to get moved back to the population centers.
Hmm.
Um,
So that is presumably like the natural gas power plants are just like in industrial areas in or around the cities.
yeah, I mean, so the yeah, right. So yeah, gas plants are kind of uh, all over the place. Um, Coal plants, to the extent that they exist still in Texas, are kind of all over the place. Um, we do have a couple of nuclear plants, the South Texas project, and then Comanche Peak. Um, the South Texas project, as the name indicates, is kind of in the south of Texas,
Uh-huh.
and um, so those are a little bit more. You have a little bit more flexibility, I would say, in where you want to put those.
Uh-huh.
Um, Whereas the wind plants kind of have to be out west. We do have, like, I suppose you could have some offshore wind on the coast.
Uh-huh.
But for the most part, most of the wind is out in West Texas.
And uh, when they've been building these, so it's been like the last 20 years that they've been building them. Has there been like what are some of the issues that come up that aren't advertised in the commercials that
Mhm. Yeah, so I think you have a lot of the same issues, pro and con, that you have with oil and gas development. So there's concerns about, um, there are disputes for oil and gas. You have disputes about pipelines and building pipelines. There's eminent domain issues that come up,
mhm.
and you have similar things with the transmission lines. Um, in both cases, there are issues of, like, people will sometimes complain about noise or blight or things like that.
Mhm.
Um, on the other hand, both they both are similar in terms of you know property owners getting royalty payments,
Mhm.
that sort of thing. So I think my impression is that overall the turbines are pretty popular. I mean, for one thing, you are talking about a very rural part of the state, so there's
Mhm.
not a whole lot of people around.
There aren't that many people to complain.
Yeah, right, right. And while West Texas does have its own kind of inherent beauty, it is also kind of like
Barren
it's part of the
wasteland.
Great Plains. Yeah,
Uh-huh.
so there's a lot of dust and dirt.
Uh-huh.
Um, so I don't know that, like, being able to see a windmill out there necessarily that bothers people all that much. But of
Does
course, you know,
the dust in the air, like how do you know how the wind turbines might be different in Texas than say in Indiana?
so I think so one of the things that has happened to the turbines over time, I know, is that they have tended to get a lot bigger and taller. Um, so I don't I don't know how tall some of the Indiana ones are, but that's probably a difference. Certainly, and as we may as has become, I think, apparent over the course of the last month, um, the turbines in different areas are adapted to different weather conditions.
Mm-hmm.
So probably, if you have a wind turbine in West Texas, you're not as adapted for cold weather as you might be in Indiana, for example.
Which we recently found out.
Yes, yeah.
So,
But
because
you would be one. Yeah,
I imagine
but
if you have a lot of dust blowing around, because these blades can be moving, especially the tips of the blades can be moving pretty fast. And so I'm just curious if there's a lot of
yeah.
dust in the air, if it wears the blades out faster than they would be worn out in other
I
places.
don't. I don't. Yeah, I haven't heard anything about that, so I don't know. It doesn't seem like it's a huge problem, um, particularly at that. If you're talking about like 100 feet up or whatever, I don't know.
Hmm.
Um, but yeah, they also. I mean, there is an issue of like things flying into the blades, bats or grackles or birds or whatever.
Hmm.
Um, but again, I don't know that is a huge that has a huge impact on the operability of the blades.
Uh-huh. And then how much infrastructure does it take in terms of how much investment was there in this transmission, being able to transmit the energy from one place to another across the state? Because now instead of having like a single power plant where you have a gigawatt of electricity coming from something the size of maybe a football stadium,
Yeah.
and in order to get a gigawatt of wind power, you're probably looking at there may be 10 megawatts a piece, and so you have 100 of them, 100 turbines to
Right.
get the equivalent of that's a peak power, so you maybe have 300 turbines
Hmm.
to deliver a
Yeah.
gigawatt.
So the Cresline project in general, that cost about $7 billion. Um, that's not like per turbine or anything. That's like
Right.
for
The
for
whole
the
thing.
whole line. The way Texas transmission works in general is uh, a little bit different. So for parts of our market are open to competition. They're based on competition. So people just, if you want to build a power plant of whatever type, you pony up your own money to do that. Transmission lines, the costs are socialized.
Hmm.
Um, so if the transmission line gets approved, then it gets built, and everybody in the state,
So they're like roads. They're treated like roads.
yeah, right, yeah, they're like roads or other pieces of infrastructure. Now, I will say that individual transmission lines compared to the cost of a power plant, they tend to be cheaper. Although I will also say that the amount that we have been spending in Texas on transmission has been going up, whereas our other costs have been going down in recent years. So transmission is becoming a bigger part of the overall cost picture.
Uh-huh.
Um, Kind of hides some of the other gains that we've had in the system.
So I wonder if you look at the average distance between the producer and the consumer,
Yeah.
and you compare that to the cost of the transmission lines, like the excess cost in transmission, if they're, that'd be an interesting, I guess, question to ask is the extra cost in transmission due to the fact that the grid has more miles of cabling and therefore takes that much more infrastructure to manage?
Right. Yeah. 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 I don't know. So that's a good question. I don't know if it's just a result of more lines or if it's a result of uh, you know higher costs per mile. I do know that with transmission, what often happens is um, there could be a low hanging fruit problem, right, where the cheapest stuff gets built out first,
Uh-huh.
and as time goes on, the every additional mile that you want to do is going to be more expensive.
Right.
You know, uh, and I mean that's also true. I think for some of the turbine siting, you're gonna if you your
Oh, you
first
find
wind
you find the cheap windy parts
right.
first, and then you.
Yeah, exactly. Yeah.
Okay.
Yeah.
Now, with the energy in Texas, so there's been a fairly significant transition. What kind of wedge did wind carve out of the Texas energy portfolio over the last 20 years?
Yeah. So I think the biggest the biggest change is probably not actually wind, but natural gas. So we used to be natural gas was number two in terms of the source of electricity in Texas. Coal was number one,
Mm-hmm.
and coal was not a uh, it was not a blowout, but they were the largest source of
Yeah, well,
electricity
and that was
generation.
true across the country, clear until like at least the 90s.
Yeah. It's definitely it was true across the country. It's still more true across the country than in Texas. I think the shift in Texas has been more pronounced, where natural gas is it's now a majority just on its own. It's a majority of the electric generation, and coal has fallen, and then uh, first coal was falling, I think, being taken over by natural gas, and now coal is actually in third place behind wind. So wind would be about 20% of the generation.
Mm-hmm.
Coal is just under 20%. It's falling just under 20%. Natural gas is about 50%, and then we do have a little bit of nuclear and a little bit of hydro, but not too much.
Mm-hmm. And then
And
and then
very
some solar at
tiny
the
amounts.
bottom. Yeah, so I showed the graph to my class the other day about like there's one nuclear plant I guess that went down in the most recent episode of.
Yeah, well, there was
Um,
one of so the plant has like four different units, and one of the units went down. Yeah.
uh-huh. So when you look at the electricity produced by source, there's all these wiggly lines from everything, and then nuclear is this
And then
flat line, and then it's got to jump at one location.
yes, right. Yeah. Yeah, that's kind of the nature of nuclear in general is that it's kind of a binary. It's on or off,
Uh-huh.
right? Whereas some of the other plants, you can kind of maybe you can keep operating at half your capacity or half your potential or whatever.
Mm-hmm.
But yeah, for the nukes, not only is there's not a lot of them, but then it's just like you can definitely see, okay, that's where it went off and that's where it came back on.
Uh-huh.
uh,
Now with so what explain like how did the situation in Texas unfold back around I guess it's almost been just under a month now.
yeah,
Like what precipitated what?
sure. So I think the broad thing to keep in mind is that in with electric systems, as you alluded to earlier, you got to keep a balance between generation and consumption, between supply and demand. There's not really that much storage on the system, so you got to keep that balance to keep the frequency at the right level to maintain the system, and that means that most systems are geared around they're designed around being optimized for the peak demand period.
Mm-hmm.
And in Texas, that has traditionally been in the summer, right? So everything is designed around being able to operate really efficiently, and at maximum during the summer when it's really, really hot and people are using their air conditioners and so on and so forth.
Mm-hmm.
So we're not here in Texas so used to extreme cold. So we had this cold weather event starting Valentine's Day weekend, and it was probably I think the last time that we had a situation that was that cold in Texas was in the 1890s.
Mm-hmm.
Um, and I don't know, there's some other elements as well where not only was it that cold, but it was cold for a really long time across the entire state, and there was also a lot of ice. So you have a lot of really extreme cold events that are not typical, and so therefore the system is not optimized for that.
Mm-hmm.
And that does that. So that did two things. First is that really increased electricity demand because people are trying to heat their houses, other things like that. They're using electricity. So we ended up having. It was projected that we would have had an all-time electrical peak during the winter. Even higher than what we normally have during the summer.
Oh, really? So it's like everybody going out and getting space heaters.
Right. Yeah. Right. So we didn't actually end up reaching that. We did reach a all-time winter peak. We probably would have reached an all-time peak if we had had enough power. So that's one side of the equation. But then
okay, so the weather event that it was completely out of phase with
right. Yeah. Exactly.
the standard operations and maintenance schedule of the grid.
Right. Yeah. So that was one thing, and that if it had just been a demand side issue, there might have been a few rolling outages, something like that, but it would not have been a huge thing. I don't think the bigger problem happened is that for one reason or another, a lot of the plants were not able to function in the cold weather,
Mm-hmm.
and there have been a lot of there's a lot of specific explanations for why that happened in individual cases. We're still trying to sort out what are the biggest factors.
Mm-hmm. So you're saying that not every natural gas plant failed in the same way?
Correct. Yeah, and not every natural gas plant failed. Right. There was even during the lowest point, there was still a lot of natural gas on the system.
Mm-hmm. Now these power plants are somewhat individually owned. Like you might have a consortium or like a group that are owned by.
Yeah, they're all. So we do have. There are. So most of the state is in competition. So the generators are all. You have a company that you own the generators and then you sell. We do have a few electric co-ops. So those are regions where in a co-op the customers are the owners,
Mm-hmm.
and so they might own their own generation. Potentially, they might own some units, and then we also have a couple of cities that got grandfathered in, and they have municipally owned utilities, and some of them own their own generation as well, but they also buy off the grid.
Mm-hmm.
But for the most part, you're talking about, it's a bunch of different companies that own a bunch of plants.
And are the plants kind of assembly line style plants, or are they all somewhat different as well?
Yeah. So the plants can be different as well. So you have some plants are kind of geared towards just being on all the time, providing their maximum power all the time, right?
Mm-hmm.
Nuclear plants is like that. A lot of the coal plants, that's what they try to do. By contrast, there are other plants that are so-called peaker plants, and some of them are basically just a bunch of jet engines strung up together.
Mm-hmm.
And they are designed to only be used during periods of peak demand, right? Mm-hmm. They're only expected to run a few days out of the year because they're very expensive to operate, to generate electricity from, and so they only come online when there's high demand. And so when there's high demand, the prices go up the wholesale.
Okay, so they operate. So this would be like natural gas plants, but they're not combined cycles. They don't have the steam cycle going at the same time with the exhaust.
Right.
They just turn on, and it's just like turning on a jet engine, like you mentioned. And then, so I'm surprised that so they only operate. You would only turn them on when the cost of electricity is like when you can demand enough from the customer to justify wasting like 20% in efficiency or something like that.
Right. Yeah. So they only operate basically. They're designed to like get the high price periods. That's when they want to make their money.
Mm-hmm.
And they sort of have to do it that way, because if they were to, like, most of the time, the price of electricity is like, I don't know, $30 a megawatt or something like that. If they were to operate under those conditions, they would be losing a ton of money.
Uh-huh.
But if it's $3,000-$4,000 a megawatt, then it would make sense for them to
turn on. Okay.
And then of course there's also the variable generation, intermittent generation, like wind, where they just they're not base loads. They're not designed to run all the time because the wind doesn't blow all the time, but they are designed where whenever they do run, they want to sell into the market, right?
Mm-hmm.
So whenever there is wind, they try and bid into the market and provide that generation. And they have the wind, like the fuel cost is zero for the wind, so they tend to have pretty low marginal price they're willing to accept from
mm-hmm.
the grid. So the different
so they basically say, hey, we'll sell our electricity for some amount.
Right. Yeah. So they have an auction. Yeah.
Uh-huh.
It like the way it operates is you have an auction, and
is it a real-time auction?
So they have a real-time auction. There is also there's a day-ahead market, and a lot of people also will have fixed contracts. Well, they'll say, like a city or somebody will say, okay, we're going to buy electricity from you, power plant, at this particular price, right?
Mm-hmm.
And then the power plant says, okay, we'll deliver it to you for this price. And then if for some reason, if you have a fixed contract with somebody and the plant is not able to deliver, then the plant has to go to the market and purchase the electricity for you.
Mm-hmm.
So they do it via auction, and everything was going well into through that Sunday, February 14th, Valentine's Day, into the early morning. And then at a certain point in the early morning, you started to have a lot of power plants fail. They kind of left the grid, right? And that started it was difficult for the system operator, ERCOT, to maintain frequency, and so the frequency started to drop,
mm-hmm.
and they ended up having to shed load. They told the different distribution folks, okay, you need to cut off power, right? Because we're not getting, the whole system's going to go down.
Mm-hmm.
We can't maintain frequency, and so they ended up shedding.
So what do you mean by maintain frequency as opposed to like maintain? So in my mind, I would be like, you have to maintain the voltage. How does the frequency drift?
So you have to maintain 60 hertz.
Uh-huh.
And if you go below 59.4 hertz for more than a couple minutes, that starts to damage. It starts to damage the lines. It can damage the equipment in the plants, and then.
Mm-hmm. Now, is that what would cause something to drop in frequency? Is it that the load becomes too strong?
Yeah. Well, no. If you have a mismatch between the amount of power that you're demanding and the amount that is available,
mm-hmm.
it kind of gets spread out and diluted, is one metaphor you might use. Like if you have, let's say you have 70 gigawatts of power generation that's available,
Mm-hmm.
and people are trying to use 71 gigawatts, right? There's an
Mm-hmm.
imbalance there, and so it kind of like if you don't either increase the supply up to 71 or reduce the demand down to 70, uh, the electricity is not able to match, and that drives the frequency down.
Okay.
But,
So the load basically is too hard on
right.
the equipment, and everything kind of slows down.
Yeah,
Okay.
and that's. I mean, we were talking. I don't know if it was before the live stream started or whatever, but the blackout in the Northeast 15 years ago, you may recall, in or
2003.
even longer. Yeah, it's almost 20 years ago now. Um, the reason why you had that blackout is because it started. They had a sensor that wasn't working, and there was a transmission line that was down, and that caused an imbalance, and it just kind of like it spread because the imbalance. When the frequency goes too low, there are there's kind of like safety mechanisms that shut things off.
Uh-huh.
Um, and
Yeah, so it's an interesting picture when you look at that one from 2003 that you can see the United States with a gigantic wedge cut out of it.
Yeah, exactly. Yeah,
Like North Korea transplanted onto the.
Right. Yeah. So that is, that's what you want to avoid at all costs, right? Is having the whole system going down. And so when you're in that situation, that's what our car did. Is they said, okay, we can't get the supply back up. The supply is failing, so we have to, involuntarily reduce demand, right? So they would tell Austin or Houston or whoever the local providers are, okay, reduce your demand by this month.
However you want to do it.
Yeah, right. Or however you can do it. So why were those power plants going offline? One thing that we know is that when you have cold weather, some of the equipment or safety equipment at the plants can freeze and stop working. So that's what happened at the nuclear plant. There was a sensor that froze, and without the sensor, they had to shut down because they can't. If you can't tell what's going on at a nuclear plant, that's a problem.
That usually isn't the way that things want to work. And then when you turn a nuclear plant off, you have to wait for 3 or 4 days before you can turn it back on.
It takes a while to get it back up. Yeah. So that's one. Another issue particular to the natural gas plants is just in the same time you had a lot of electric demand, you also had a huge demand for natural gas for home heating.
Now, what fraction of home heating is electrical versus natural gas?
In Texas, so that's a good question. I think I don't know if it's like half and half, or if it's a majority used for heating. But there's a lot of both.
Because I know in Seattle, where I went to graduate school in Seattle, and a lot of the homes were just electric heating. Where, like when I was in Illinois, all the heating was gas, and like the dryer runs off of gasoline. So we had a gas dryer in Illinois. We have an electric dryer in Nevada.
Yeah, I think it. Some of it kind of depends on how new it is. Electric heating, I think, is more new in a lot of newer homes. Will have it as opposed to gas. But in any event, and I should also say, we're talking about Texas because that's where the bulk of the issues were. But if you look at the other regions that border us, to the east you have the Southwest Power Pool, to the north you have MISO. Both of them also had rolling outages, blackouts, supply problems, right, because of the demand and other failures. So,
but why point that out when you can score political points by making fun of Texas?
Yeah, right. So anyway, so there are definitely plants that say, well, we were not able to get gas, right? Either there was a supply shortage, or there was problems with the pipelines, or there's other things, we were not able to get gas. And then a third issue, which I think is still being worked out. There have been kind of claims and counterclaims about this. Is as I mentioned, when the frequency when the frequency drops on the grid, there's a risk that you can damage your equipment, right? From overheating or overloading it or whatever. And so a lot of plants have kind of automatic triggers where if they sense that the frequency is getting too low, they will just take themselves out of the grid automatically so they don't get damaged.
Which then forces everything else to shut down. Right,
yeah. So there's been a dispute. ERCOT, the system operator, has said things did not get low enough for long enough that should have happened, right? But there have been some plants that said, no, yeah, we ended up having to do that. So that's a dispute, we'll talk about. But overall, it seems like mostly it was due to operation problems. And there are some cases where like a plant has said, well, when they did the initial curtailments, they cut off our electricity, and so we weren't able to operate to produce more electricity because we didn't have the electricity, which is there's a kind of weird circular thing there, because a lot of the natural gas plants their pumps are electrified.
So if they lose electricity, then they can't.
Right. Yeah.
Yeah. They don't. They need their equivalent of their pilot light.
Right. Yeah. Exactly. Yeah. So that's like kind of a weird circular thing.
Now, one quick question that came up is when you mentioned that if something costs $30 a megawatt or something, is that a megawatt hour? Is the
correct? Yeah, megawatt hour. Yeah, and normally the price is pretty low in Texas, but it can go up to. We have a price cap of $9,000 per megawatt hour.
And what's the average? And how does that compare to we'll make fun of California since they're the other one that Texas gets compared to California more.
So I think your average is probably going to be more in the $20 to $30 range.
Wow, and it can go up to 9,000.
It can go up to 9,000, and so that's the price cap, right? So it's in fact before this last event, I think it had only ever gone up to 9,000 for a few hours once, right? So most of the time, it's nowhere near that. But it is designed so that most of the time it's pretty low, but for a few days a year, it can get really high, right? And in this case, you would expect it to be pretty high, both because of the scarcity and also because
the competing demand for gas.
Right. So natural gas prices themselves were upwards of $1,000. I think it was like $1,000 per million BTU or something. I'd have to look it up. But yeah, it was the natural gas prices were pretty high themselves, which of course raises the cost to produce electricity. Because that's a fuel input.
Yeah, so I guess that's one issue certainly the market is aware of this, but when you have heating and electricity production using the same fuel source, that you can have these kinds of market competition things, which is, it drives the most efficient use, provided that the consumer knows at the time. If the consumer knew in real time what they were paying for something, that it may have changed their behavior. But when the bill comes 2 or 4 weeks after the fact, it's kind of hard to modify your behavior when you don't get information until it's already over.
Right. Yeah. Exactly. Yeah. Let's see here. Just trying to get an exact number of what the high was.
In Wichita Falls are up.
All right. Anyway, I was going to try and look it up, but there's too many pop-ups.
Okay. So, how does electricity prices in Texas compare to California? Do you know that?
So the average. All right. Let's see. So I know that we are so our electricity prices are lower than the national average by about 8 to 10%, something like that.
Mm-hmm.
I don't know about uh, what exactly it is in California. So in California, electricity in California is pretty expensive.
Mm-hmm.
So I think I'm looking here, it's about like 20, 20 cents a kilowatt hour,
Mm-hmm.
uh, compared to in Texas for. I guess that's retail. So uh, the Texas retail rate is probably going to be more like 7, 8 cents,
Oh
something
my
like
gosh,
that.
that's like 4 times smaller,
Yeah. Well, I mean,
or
it's less
three.
than half. It's less than half,
Uh
right?
huh.
It would. Um, so yeah, let me just double check. So this has it about like 10, 11 right now. So
Okay, so
versus
it's
yeah,
like
so
forty
it's about
percent.
half.
Uh
Yeah,
huh.
it's about. Um, so yeah, I mean, this has definitely been one of the big draws of Texas. Traditionally, is our electricity prices are pretty low, and they've fallen a considerable amount.
Mm-hmm.
And part of that, I think, is that traditionally the uh, electricity price has tended to, since we use so much natural gas, and that's kind of like the marginal fuel. Electricity prices have tended to follow natural gas
Uh
prices.
huh.
Natural gas prices have been,
Falling
they've
significantly over the
fallen,
last.
yeah, right, yeah, pretty low.
Uh huh.
Um, and then we also, the wind probably helps too, because that tends to be, when that's on the system, that's pretty low as well.
So when you have the how do you know how the regulatory environment might differ from Texas compared to other places? Like what
Yeah,
kind of
so,
restrictions do the different companies have to operate
mhm.
under?
Yeah, so a lot of states um, still operate under a vertically integrated system.
Mm-hmm.
And in a vertically integrated system, you have a single company, a utility in a geographic area that owns and operates everything.
Mm-hmm.
So if you are, uh, if you move into a house or apartment, and you want electric service, you have one option, right? It's the
Mm-hmm.
utility. You call them, they turn you on, and the same company is your retail electric provider. They're also the distribution utility. They also own the generation that they are using. So it's vertically integrated. All the parts of the system
Mm-hmm.
are as a monopoly. And then in those systems, because it is a monopoly, they are subject to heavy oversight and regulation by the state Public Utilities Commission or Public Services
Mm-hmm.
Corporation, whatever the utility regulator, who has to approve their
Rate
electric
hikes.
rate, has to oversee a bunch of stuff. Um, so that's the way it's done in a lot of states. If you are in a state that has that is, I guess, the jargon is like restructured, a restructured state where you have retail choice and generation competition,
Mm-hmm.
then prices, you will have a choice of provider, and uh, prices are set by based on the market, perhaps
So
with
how
some.
do you choose, like, who gets to make the choice, and how do they choose where they get the electrons from?
Yeah. So in Texas, you mean?
Yeah.
Yeah. So if you're in a competitive area, the consumer gets to make the choice. There's a website that you can go to.
So who's the consumer? Like the actual household? Like.
Yeah, like the household, or if you have a business, or a factory or something
Uh huh.
as well. Yeah, it's the same thing. It's sort of vaguely similar to how it used to be versus how it is with your telephone service,
Okay.
right? It used to be, if you wanted to phone service, you would call the phone company,
Uh huh.
right? They would turn you on, and and that's who you deal with. And then after you had telecom reform, now and particularly now that everyone's got smartphones, like you can go to Verizon, you can go to AT&T, you can go to T-Mobile.
Okay, so let me see if I get this, if I can piece this together. So you have this grid. The grid is basically public, right. And then you essentially buy energy from some provider, and they're just going to put it on the grid, and it's going to get consumed. But
so the retail electric providers, they tend to be they're more like middlemen. So you're not buying directly from a power plant or anything, right? What the providers say is, okay, well, usually what they'll say is, okay, we will offer you such and such a rate per kilowatt hour. And that's kind of a fixed rate, and there's some other charges, administrative charges or things like that. But it's a fixed rate. We're going to provide you that, and then they go out and make purchases either from generators directly, or they buy off the from the auction, from the real-time market, the spot market. So that's kind of the operation on that side of it.
Okay, so you pay for like a broker to manage your energy portfolio.
That's right. Yeah.
And are they the ones that make the decision about so then they're the ones who make the decision about where they're going to source the electricity from?
Right. And there's an element of accounting to this, because in one sense, the electrons are kind of all the same. So if you as a retail electric provider, if you say, okay, I'm going to buy from this generator 10,000 kilowatt hours or whatever, right? All you're really saying is, I'm taking this much off the grid, and they're taking that much on the grid, and
right. Paying, and however it gets, and it's just
whether it's really the same electrons.
It gets put into the big. Well, it's not. It's obviously not going to be the same electrons, or I guess they're all the same electron. So exactly. They're all fluctuations from the same electron field.
Right.
But but it's basically just a commitment that someone's going to provide something, and someone else is going to consume it at a known price, and then they just make it, put it on the grid, and then it gets consumed.
Correct. Yeah.
Now, how has that? When did this kind of restructuring take place, and how has that been in general for Texas the last month, notwithstanding?
So the restructuring, it started in the 1990s, started in 1995, and was more or less complete by 2001. So you had it happened in a couple of stages. So it's been about 20 years. Overall, I would say it's been pretty good for the state. Our electric rates have fallen, I think, like 30% since restructuring. So our rates are pretty good. We're below the national average. It's allowed a lot more variety in terms of what are the individual products that people might want.
So along those lines, so since if it is a real market, then that implies that everything has to compete in a real market. So have there been any subsidies for adopting wind, or did wind just make sense and therefore it was used?
So there definitely are subsidies for wind. Most of the subsidies are federal as opposed to state. So you have a lot of states have what's called a renewable portfolio standard, and most states do that in terms of percentage of the total it says some percentage has.
Yeah, Nevada just signed on to one of those.
So Texas has one, but it was not a percentage. It was like an absolute number, and the absolute number was pretty small. So we had to have a certain amount by a certain date, and I think we ended up achieving that 10 years in advance, and now we have some huge multiple of it. So,
Uh-huh.
and you look at like they have like a credit system. Basically, how they work it is like you have to buy these credits, and the credits are like pennies,
Uh-huh.
pretty small. So that's a small subsidy.
So if someone
There,
were to could someone build a wind plant today without the subsidy and compete favorably on the Texas market?
yeah. So let me just complete the picture, because there's also there's a federal subsidy, there's a federal tax credit called the production tax credit,
Mm-hmm.
which basically gives it's like 2 cents per kilowatt hour generation from wind, right?
That's like 10%.
So, yeah,
20%
so
in
it's a
Texas.
sizable credit. Yeah, so it's a sizable credit. It definitely, I would say, has encouraged more deployment of wind onto the system.
Uh-huh.
Yeah, so that has had a real effect. Without that credit, there would not be as much wind on the system in Texas. I would say, however, that even if you take that away, the cost of producing wind and developing, building wind turbines has fallen quite a bit over the
Uh-huh.
last decade or so. So you probably, even without that subsidy, would have seen an increase in wind generation on the system. There just would not be as much of it.
Uh-huh.
Yeah, if that makes sense.
Yeah, but I mean, at 20%,
Yeah, I mean,
20% subsidy at the retail end, to me, that's enormous.
Yeah, it's a sizable. There's no lying. It's a sizable chunk of change.
Uh-huh.
And you do. It also, one of the weird things that you have because of that is sometimes you will get a strange phenomenon where the price of electricity will be negative.
Mm-hmm.
Because if you are a wind generator and you're getting 2 cents in a tax credit per kilowatt hour, it can make financial sense for you to bid into the system at like, negative 1 cent, right?
Uh-huh.
So take this electricity, I'll pay you 1 cent, I'll
Uh-huh.
get 2 cents back from, from the tax credit.
Like oil at the beginning of COVID.
Yeah, right, yeah. So yeah, which is kind of like a weird phenomenon.
Uh-huh. Okay, so there are fluctuations. This is like an average retail value. At the same time, so I'm personally not really a fan of subsidies because I think that it hides information from the consumer.
Yeah, I'm not a fan of subsidies either. I don't like the PTC. I don't like particularly the.
What is PTC?
The production tax credit. That's the subsidy.
Okay.
Yeah. So I'm not a fan of that. I'm definitely not a fan of the renewable mandates. I don't think that's as you say, it's like hiding information, and it creates a distortion.
So let me the way that I think about this, and I could be wrong, and so if I am wrong, tell me. But the model that I have in my mind about how this works is, unless you're actually building whatever it is, if you're building wind turbines,
mm-hmm.
unless the energy that you're using to build the wind turbines is coming from the wind turbines, mm-hmm. Or some other renewable resource, then the price of whatever it is proportional to the carbon footprint, because most of our energy comes from fossil fuels. The oil, natural gas, so like 80% of our energy in the United States comes from fossil fuels across all sectors. And so unless you're building your infrastructure, you're building your wind turbines somehow knowingly out of only the 20% that is renewables, or the 10% or whatever that's renewables, then the cost is proportional to the carbon footprint. And so having to subsidize something indicates that it actually has a bigger carbon footprint than what the alternatives are.
So I guess what I would say is there's the cost to build the plant, or to build the generator, and then there's the cost of actually operating it and running it, right? Mm-hmm. So for a coal plant or a natural gas plant, most of the carbon emissions associated with that are not going to come from actually building the plant. It's going to come from burning the fuel, mm-hmm. right? And that there's not really an equivalent for that for the wind, because
there's no fuel cost
there is the wind.
But then
right?
the price, but there's price in concrete and steel and
Right. Yeah.
cabling
So
and
the
infrastructure.
right. Yeah. So I think what you're saying makes sense for like actually building the turbines as it would for like building the natural gas plant or whatever. But I don't think that would totally work out because there's the additional factor of like having to actually burn the coal or the fuel or whatever, right?
But that's factored into the price, isn't it? The price of maintaining the wind turbines versus the price of burning the fuel in the.
Uh, so in terms of like, well, yeah, I don't would that. So there is no fuel cost
Uh-huh.
for the wind turbines because once the turbine is built, uh, the wind is free or so ever. There is a fuel cost for natural gas and coal, but the carbon content, we don't have a carbon price, so the carbon content isn't part of that
Mhm. That would kind of
cost.
solve everything if there was a
Yeah, right.
if there was a
Yeah,
carbon tax. So there were a couple of questions that came up. Now, one of them about the subsidies to renewables versus subsidies to fossil fuels. My understanding is the total subsidies to fossil fuels, and it also depends on what counts as a subsidy. And
right.
I'm actually not convinced that people who report these things actually count subsidies the same across the industry.
Yeah.
So like I read somewhere, and so in some nebulous article that I read on the internet somewhere,
Yeah.
that they were counting things like if you drill a well for oil, then you can count, and there wasn't any oil there, then you can count it as a loss, and that was treated as a subsidy by this particular study. And I'm like, that sounds like a business expense cost.
Right.
That you would get the same thing if you were an accountant and you bought a piece of software and you deducted the software off your taxes. So to me, that just made me think that I find it unlikely, unless it's the same person who is like, here's what I'm going to count as a subsidy and here's not what I'm not going to count as a subsidy, were to do this study. But that being said, the numbers that I've seen reported is that basically fossil fuels get something like 3 times the amount of federal subsidies as the renewables. However, so if you're in one political party, that's the number you want to quote, is we give
Right.
3 times the number of subsidies to fossil fuels as we do to renewable energy. And then if you're in the other political party, then you would say, yeah, but we get almost 10 times the amount of energy from fossil fuels as we get from
Right.
renewables, and therefore that takes it from a factor of 3 to a factor of 0.3. And so per terawatt hour, which I think is actually the right number, per terawatt hour, fossil
Yeah.
fuels get far fewer subsidies than renewables do. Personally, I think that no one should get any, but I guess it depends on what you mean by a subsidy, right?
Yes, and so this quickly can devolve into like almost metaphysical or philosophical questions of like, well, what counts as a subsidy or what doesn't. We have actually done. Our street has done a couple of reports on this. So that we're part of a project called Green Scissors, which looks at different fossil fuel subsidies. We also did a report. I did a report a couple of years ago. I think it's called Leveling the Playing Field, which looks at different subsidies, different provisions of the tax code, both for fossil fuels and for renewables, and tries to make like a principled case of like, okay, what should actually be counted as a subsidy and eliminated versus what is, as you say, a ordinary business expense or something else that makes sense. So there's that, but the basic picture as you laid it out, I think is correct, which is that if you just look at an overall absolute number, the fossil fuel subsidy is going to be bigger, but if you go on a per kilowatt hour, per terawatt hour, or whatever basis, it's going to be more for renewable energy. And the only other thing I would add to that is that as you say, like I agree. My position is you probably shouldn't be subsidizing any of them. And increasingly, an argument I see from people is, well, the renewables get more subsidies, so we need to have more subsidies for other sources too, right? And if you were to add up the price tags of some of those things, maybe the picture would change. I don't know. There was a there was a bill in Ohio recently where they said, okay, we're gonna get rid of the renewable subsidies that we have and basically give the money as subsidies for some nuclear plants that
Mm-hmm.
were there. So that wasn't great. And then, as it turned out, the nuclear the company that owned the nuclear plants was bribing the Speaker of the House
Oh my gosh.
in order to pass this legislation. So now they're working. So he's gone now,
Uh-huh.
and they're trying to figure out.
Do you think
what
if if we paid politicians more, that this would happen less, or do you think that it would happen more?
Yeah, so that's a good question.
It seems like you get what you pay for. You have politicians are paid basically like lower middle
Yeah.
management salaries, and so you get lower middle management quality of the.
Yeah, that's possible. Although the amount of the bribes in this case was, I think, 60 million. So that could be some hefty salaries that you're talking about. I
$60
actually
million.
$2 million. Yeah, not all for one guy. He had to spread it around a little bit.
Okay, so $30 million.
Right. Yeah. Actually, I think
For the big man, was it the big? Did he call him the big man?
I don't know what euphemisms they use in that case. And the same thing actually also happened in Illinois, again with the Speaker of the House there, again with some nuclear plants. So yeah, my perspective actually on this is, I think a bigger problem is that when you have government officials, politicians, too involved in like making decisions that affect whether a business is going to succeed or fail,
Mm-hmm.
then there's a greater opportunity for businesses to try to succeed, not by delivering a better, cheaper,
But by pulling political strings and lobbying and stuff like that. Oh, yeah,
Right.
I can definitely see that. So you have an issue where, and it also runs into the thing like, how do you pick the bread czar? Who's going to
Right.
determine how many
Yeah.
loaves of bread are baked in a given location?
Right.
And this is way beyond, like, the intelligence needed to choose, for example, how many loaves of bread should be baked in Las Vegas.
Right.
I was trying to think about that just the other day. And I was like, that's too hard. You have to it has to be done as distributed as possible to make those kinds of decisions.
Yeah, that's right. I think there's a famous case during the Cold War where the Soviet ambassador in
It
England
was in London, yeah.
Yeah, he was like, well, who's in charge of deciding how much bread is made for London? And they're like, no one's in charge. And he didn't understand. It's like, wait, someone's got to do it. Like, there's bread. I go down to the store, there's bread. So someone must be deciding, how much bread should be made.
Uh-huh.
But yeah, this is the one of the curious facts about the world is that if you have someone who's in charge of deciding how much bread there should be, there's not going to be any bread on the shelves, right?
Uh-huh.
If you don't have someone in charge of, making sure that there's, the appropriate level of bread, then you will be able to get the bread most of the time.
Mm-hmm. So that's interesting. Yeah. Okay, so I'd never articulated it quite that way. That one of the issues is that the more, especially because politicians aren't necessarily informed on those subjects,
Right.
and so they're not. So they're going to make decisions based upon, I guess how they're feeling that day, and less upon real information.
Yeah, I think
maybe in one field they might have the information, but no
Right.
one's an expert in everything all the time, except for your friendly neighborhood physicists.
Right.
Everyone else is going to have
Yeah.
might have a hard time, knowing how to handle every aspect of society that they're asked to legislate.
Right. And I think there's two issues here. There's like an incentives issue and there's an information issue. The information issue is, if you have like electricity policy can get very technical, and when you have monopoly utilities, they basically have all the technical expertise and information. So when a legislator or politician is trying to figure out, okay, what should we do? It's going to be natural for him to go to the utility to say, hey, can you help me make sense of this or other stuff like that? And they, of course, are self-interested, right?
Mm-hmm.
And so that's part of it. And then the other element is the incentives issue, which has to do with money and you know uh, uh, people are influenced by that, right? Even
Mm-hmm.
if it's not good. So both of those, I think, are kind of a political advantage of having competition. Is that um, those factors are not as important.
Uh-huh. Okay. One other question that came up earlier was transmission fees. What is, let me see what this says. What does Josiah think about transfer fees? What is a transfer fee?
Oh well, I don't know. So it's not. Is it
Coal is used in the subsequent sentence.
okay?
Coal plants make a lot of money on transfer fees. There is a giant investment in tax credit.
Oh, I think he's talking about a particular. He's like highlighting a particular subsidy.
Uh-huh.
I think that you and
So he's
yeah.
in the Pacific Northwest, this particular.
Okay, yeah. So I would say first, uh,
Moving electricity from one region to another.
yeah. So,
Um,
if you go again, some of the stuff is dealt with in like the reports where we talk about a lot of specifics. But yeah, I mean, there definitely are. I would say you can point to examples of um, preferable tax treatment for fossil fuel plants that I would say would count as a subsidy, and it may be that he's identified
mhm,
one there, right? Just based on like how you move electricity around, and so on and so forth.
mhm,
It sounds like that maybe is what he's asking about. So yeah, I mean those things definitely exist.
uh-huh. Okay.
Um,
Is there any, if you want to have the last word on what happened in Texas, like what lessons have been learned so far, and what lessons do you think will be learned in the next few months? Um, at,
yeah. So I think the big issue. I think one of the big issues, and this is a kind of general tendency, is that when everyone was doing their forecasts, they basically went with, well, how bad were things during the last bad winter storm, and then they treated that as kind of a worst case scenario,
mhm,
right? So ERCOT, they do like forecasts, and they actually did a pretty decent job of predicting what the electric demand would be in a worst case scenario. But where they failed is their worst case scenario underestimated the amount of power plant outages by half, right? So they were twice the number of plants that failed represented twice as much electricity that was not supply that was not available
mhm,
as in the forecast. So that's like I think kind of a general problem is that when the flood comes, you measure like, okay, well, what was the highest that the flood waters have ever reached? We're going to prepare for that.
mhm,
And next time the flood is a foot higher, right? And you're not prepared for that.
mhm,
So that's a general problem that I think was true across the system. It was true of the system operator. It was true of the generators. It was true of the regulators. Um, it's kind of a problem with human psychology is that we only ever kind of, I'm sure that like when people are thinking about the possibility of a future pandemic, they will think, well, how bad were things during COVID? That's like the worst, right?
mhm,
And we'll plan accordingly. And this doesn't always work out that way. My hope is, there's going to be, I think, a lot of there's already starting to be a lot of legislative changes and fixes and requirements for winterization and other things. Some of those are probably needed, but my hope is that,
you think they're going to go overboard with it?
yeah, well, I mean, so there are um, I guess I would say that there are trade-offs involved. So
Mhm. There are no
some of the things,
solutions. There are only trade-offs. That's.
right. So there are some ways to winterize a power plant which will work fine. They might cost you some money, but they'll work fine. Except they make your plant less efficient during the summer and warm weather, right?
Mhm,
So normally have a summer peak and we do a bunch of winterization, but it makes us less less able to handle the summer peak because our plants don't operate as efficiently. Then you're kind of like solving
Okay,
one
so
problem.
that's interesting. So that basically says there is a downside if you worry too much about the once in a half century snowstorm. Then what you end up with is one good year and 49 bad years.
Right.
And if your plants operate inefficiently, and right now if half your electricity comes from natural gas, then it actually means that in terms of like how good is it for the environment, if that's what someone happens to care most about, then it's actually worse for the environment to do that, because if even a 1% decline in efficiency is a huge amount of excess fuel that's burned.
Right. Yeah. So it's it could have environmental effects. It could increase the prospect of a future outage
in August.
In August. So I mean that's something that I definitely think you have to worry about. There are like one big issue that has gotten a lot of attention is our grid operator has a board of directors, and a certain number of I think it's like 5 of those directors out of 16 or something were from out of state, right? There's some in Michigan, there's some from other places, and people are really up in arms about that like these are not Texans, so they don't have the appropriate, they don't have to deal with the consequences of their actions or whatever. It is the case though that being a lot of these grid issues are not only are they highly technical, so there's not a huge broad range of people, but it's useful, I think, to have people who have experience with other grids and other situations,
other weather conditions,
right? Yeah. So I would say I don't view that as a big problem with the system. So my hope is that as we start to have a little bit more deliberation, the passion of the moment kind of fades a little bit. There's definitely going to be some changes made, but I hope that we do things that really think about the long term and really minimizing the risks and costs of these sorts of events in the future, as opposed to just some sort of knee-jerk thing.
Yeah, so I definitely, especially when people are talking about, because a lot of people are interested in climate change, especially a lot of people who are outside of Texas looking in and saying Texas is a red state. It's run by one political party. It's not all that red. It's pretty purple actually, especially when you get into the metropolitan areas. But they're looking at it to score political points. They're like, see, we should be doing all these things, but to the extent that the cost of implementing some policy is proportional to the carbon footprint of that policy, then
and I would say there is a kind of a weird disconnect in that a lot of the environmental groups in Texas really like competition. They like the fact that we have our own grid because it has allowed us to integrate a lot more renewable energy, to do a lot of other things to reduce emissions. I'm sure there's all sorts of other things that they would
I guess it puts the downside of adopting the wrong technology into the venture capitalists.
Right. Yeah.
Thing.
That's a big. Yeah. Right.
Which is honestly where I think it should be. I don't think that the government should be venture capitalists. I think that if someone develops a technology and invests in it and saves the planet, then the fact that they get a big pile of green paper on their doorstep as a consequence, to me, doesn't bother me at all.
Right. Yeah. Yeah. That's right. Yeah. It's definitely there's a risk shift away from consumers and onto either whoever's going to be building the plants or the retail providers, or other folks. So that's a big plus as well.
Okay. Hey, I really appreciate you coming on. It was interesting discussion. I hope that Texas recovers. I have family that's in Texas, and so they also hope that things are recovering pretty well, and that sensible policies prevail when it comes to all these things. But there are a lot of people who just like to spout off because they let their political party speak for them, and they don't really understand the consequences of what it is they're talking about. I have an example. I have this issue that's coming up with a conference where the cost of paper programs would be like a few $100s, And
Yeah.
the cost of getting an app where people could download the app and look at the schedule on the app was like an order of magnitude larger. It's like several $1,000s. And which one actually has a bigger carbon footprint?
Yeah.
Something that's $500 or $5,000 that,
Right. Yeah.
even though it looks like you're being environmentally friendly by having the app, that money gets spent on something. It gets spent on
Right.
heating the home of an engineer or whatever. It's not all of these things. The price is basically the only thing that one,
Right.
certainly most consumers have to go off of. And so, but anyways, it's been a really fascinating conversation. I appreciate your time. And the next time a big storm goes through Texas and knocks out the power grid, or some other some other energy policy comes up online. So personally, myself, I'm a big proponent. I really think that nuclear power, and especially the next generation of nuclear power, the 3+ stuff that they've been building in the last decade, I think it's already promising in terms of like safety and stuff like that. But I think that the Generation 4 nuclear reactors with the high temperature operations where they can use it for industrial things like fertilizer production, I think that's going to be the real game changer that really can transform the meat of the economy. Because most of the economy is not electricity. Most of the economy is other things. Transferring the meat of the economy onto something that's a clean energy source. So anyways, it's been really fascinating. Thanks for your time. And it was good to finally meet face to face.
Absolutely. Yeah.
All right.
Thanks for having me.
All right. We'll talk later.